I'm Catherine Mitchell, and I'm a professor in electronic and electrical engineering at Bath. My research is in space weather, so it's in both engineering and physics, and I look at the effects of the sun on our planet, and in particular the radiation, the particles, all of the interesting physics that goes on as that interaction between the sun and the earth happens. Space weather is literally the weather in space, so it's the ability to understand and to forecast how the sun, radiation environment, electromagnetics, particles will affect our planet. And it's really important because the sun is very variable and it effectively emits lots of radiation at different times in the year and different times in what's called the solar cycle, which is an 11-year cycle. And when the sun emits more radiation and particles, then that affects our modern technology. So it affects our satellites, our energy grids, all sorts of different technology is affected adversely by these big solar storms. So that's why it's really important to understand them and to study them. My job involves a lot of interaction with people all across the world, because there's an international community working in space weather science. And we're all tackling the same problems, but we work in different regions of the world and we come from different nationalities. But we work together towards a common goal to solve the same scientific questions.
Hello, my name is Dr. Asel Sartbayeva. I am a reader in chemistry at the University of Bath. I work on a technology which is trying to make current vaccines thermally stable so that we will be able to transport and store vaccines all around the world without refrigeration. It's important because we today lose about 50% of the vaccines due to failures of the refrigerators, or in some regions where there is no electricity to transport the refrigerators, and hence we can't transport the vaccines. And that leads to millions of deaths all around the world from vaccine preventable diseases in the age when we have a lot of very effective and safe vaccines. So with our technology, we want to make vaccines thermally stable and be able to bring these vaccines to all people who need them around the world. The technology which we are developing is called insilication. So here we use material silica. We create protective layers of silica all around vaccine components. And that stops the vaccines from spoiling when they're taken out of the fridge.
My name's David Ellis and I'm a behavioural scientist, and most of my research looks at both how technology is changing the world that we live in, but also how that technology can be used for social good. So one of the most exciting things at the moment is that we have so many different bits of technology out there, from people's phones to wearable devices to the systems that we interact with every day, that produce huge amounts of data. And I'm interested in what you can do that's useful with that data. I got involved with this largely because when I was at school, I was really interested in physics and I was really interested in chemistry. But then I sort of stepped back from those a little bit, and I became, towards the end of my school career, more interested in English and history, and somehow behavioural science sits right within the middle of those. So it wasn't always the plan, it wasn't a conscious decision, it just was by experiencing different things and learning about different things. And that's one of the best things about being a scientist, is that you have that freedom to do what you find the most interesting.
Hello, I'm Dr. Natalia Gerso. I am a developmental psychologist, which means I'm interested in how people's thinking and feeling changes over time. And I'm especially interested in this in young children so that we can better understand the roots of why adults act so oddly so much of the time. So research-wise, I am interested in 3 different areas. I'm interested in student well-being, so I'm doing a lot of work on how we design curriculums that support student well-being better. I'm interested in anthropomorphism and robots. So I'm interested in why people so naturally tend to infer human-like thoughts and feelings to robots and where that comes from in development. And I'm really interested, I've got a burgeoning interest in climate change and how we communicate with children about climate change in a way that's empowering. I got into psychology. I studied psychology at university because I was interested in people and particularly brains. But as I went through, I realized it's the big philosophical questions I'm really interested in. What makes people tick? Why do people think the way they do? And why do people think differently? And this field gives so much potential to really go about trying to answer those questions in interesting ways.